Two straight pipes, circular cylinders with radii 1 and 1/4 lie parallel and in contact on a flat floor. The figure below shows a head-on view. What is the sum of the possible radii of the third parallel pipe lying on the same floor and in contact with both? All right, so first we have to figure out what it is that the possible scenarios can be. I think it is as follows. So let me extend this line here. And this is going to be not very much drawn to scale, but let me see if I can even do it. So there's the first circle. And that circle pretty much is the exact same as the circle beside it. I know it doesn't look like that, but yeah. And then the other circle would be a circle that kind of fits in between those two. So what they're asking really is, what are the radii of these two circles? Now this one, the big one, that radii is going to be the same as this circle. So that radius is 1. But that circle, that's the circle we have to figure out the radii of. So we'll do that. And I guess we can just call it a little r. And at the end, they want the sum of those radii. So it would basically be 1 plus r would be the answer to this question. So here we go. Let's try to get r. And I'm probably going to have to draw this again. So let's see if I can do that. So here's a small circle. And I'm going to have to draw it on a bed like that. And then here's the bigger circle, well, the medium-sized circle, I guess. And then the bigger circle would be like this, I guess. It would be like kind of touching both. Let's see if I can do that. Like that. I'm not going to, well, I think that's good enough. Okay, well, you guys get the point. It's not the most beautiful drawing, but you guys understand. Okay, so how are we going to do this? Well, let me first draw the centers and then draw the tangent points. And I know this is not drawn to scale, but you guys will hopefully get the point. And then I'm going to draw these lines here. Connect those lines like that. Let's see, what else can I do here? Line from there to there. Anything else? Maybe one more line. I'll use a different color. That goes across like this. Okay, and that should be good enough. Hopefully that is good enough. Okay, so let's see here. Now we have to label a whole bunch of stuff. Okay, so I have to label all this stuff. And let's see here. This is R, this little guy here. That's R. And then from here to here would be, what was the radius of the small, what was the radius of the middle one? This circle right here. Did they give, oh, it's a quarter. Okay, so it would be a quarter minus R. Okay. And what else can I label here? This is R. So, let's see here. The radius of the big guy is 1, right? Yeah. So that means from here to here, that would be 1 minus r. And then from here to here, that would be 1 minus a quarter. So that would be 3/4. And then anything else? What else can I label? Well, I think that's all I know. So I'm just going to call from there to there A and from there to there B. And then let's see what we get. So with Pythagoras, we'll get b squared plus, let's see here, r, well, hold on here. What am I doing? 1 plus, yeah, I'm looking at this triangle right here. I should actually label it. So that would be b squared plus 1 over 4 minus r squared is equal to the hypotenuse. The hypotenuse would basically be r plus a quarter. Yeah, and then of course we have to square it because it's a Pythagorean relationship, because it's two radii that are connected. Okay, so when we do this, the b squared would be, let's see, expanding this would be r squared plus 1/2 r plus 1 over 16. And then we're going to have to subtract this when we bring it over to the other side. So it would be 1 over 16 minus 1/2 r plus r squared. Okay, so b squared, let's see here. The r squareds would cancel. These guys would actually become r. And then the 1/16 would... The 1 over 16, that would cancel also. So that means that b is equal to root r. Okay, equal to root r. All right, so the same story I guess we'll do for a squared, and let me just first identify which triangle I'm looking at here. 1 minus r1. So this guy, this one right here, that triangle. So a squared plus 1 minus r squared is equal to 1 plus r squared, because the hypotenuse is basically two radii joined together. The first radii is 1 and the other radii is r. So this looks a little bit nicer because there's no fractions. 1 plus 2r plus r squared minus 1 minus 2r plus r squared. No. So let's see here, a squared, the 1's cancel, that would become 4r, and the r squareds cancel, so a is 2 root r. So 2 root r. Okay. And fix the final one. The final triangle, let me see here, which one what am I going to use for the final triangle? I think this one right here. This one. That one. That would be the final one. So that would be basically a plus b squared. That would be the length of the base, I guess. Plus the other side is 3 over 4. And then that's squared. And then the hypotenuse is 2 radii. So the first radii is 1 and the second radii is 3 over 4, correct? Is it 3 over 4? No. It's 1 over 4. 1 over 4. So that would be 5 over 4 is the total for that hypotenuse. And then we can substitute this finding and this finding. So it would be 2 root r plus root r, and that would be 9 over 16, and that's 25 over 16. Okay. I think we can, let's see here, that's going to be 16 over 16. Okay. That's helpful. And that's the 3 root r all squared. I'll try to keep it in the same screen. 9r is equal to 1, so r is equal to 1 over 9. Well, there we go. We got the little guy. So going back, remember it was going to be 1 plus the little guy. The little guy I have calculated to be 1 over 9. So that is, well, the sum would be 10 over 9. So 10 over 9 is the answer, and that would be C. A group of 16 people will be partitioned into 4 indistinguishable 4-person committees. Each committee will have 1 chairperson and 1 secretary. The number of different ways to make these assignments can be written as 3 to the power of r times m, where r and m are positive integers and m is not divisible by 3. What is r? Okay. Well, first I have to understand this question. Let me see if I can. So we've got 4 committees, right? So, and each committee has 4 people. Okay, so let me just put in that. So here's the 4 committees, and 16 people, obviously. And each committee will have 1 chairperson and 1 secretary. All right. So I'll call it, the chair is C and the secretary is S. So this is sort of the scenario. Okay. And then the other 2, I guess. All right. Okay, what do I do now? Well, from the 16 people, you choose 4 in order to make that committee. And then when you do, you have only 12 people left over, and you choose 4 people to make that committee. Then you have only 8 people left over, and you choose 4 people to make that committee. And then finally, you have 4 people left over, and you choose those 4 to make the final committee. And yeah, that's pretty much how this would work. And the total, you'd have to multiply them all, which would be huge number. So that like that. This is the total number of committees. But this overcounts because, well, how do I explain this? Let's say you had the first committee. Each committee, I'm going to give a letter. Let's say this was the first committee was called Committee A, and the second committee was called Committee B, and so on. Well, this is similar to, say, A, B, D, C. You see what I'm saying? They're the same committees. It's just the order is changed a little bit, and so on. So how many different permutations you have? Well, you have 4 places for the A. Well, the first committee can be any one of 4 letters. The second committee will be any of those 3 letters. The third committee would be any of the 2 remaining, and then finally one choice for that last one. So the number of permutation is 24. So you have to divide all this by 24 to get the number of unique, to get a unique total. Okay, so then now we've got to actually figure out this large number here. All right, so let me see if I can do that. 16 choose, 4 choose, 12 choose. Well, 12 factorial, actually. 12 factorial, 8 factorial, 4 factorial, 8 factorial, 4 factorial, 4 factorial. And then 4 choose 4 is just 1. So I don't need to do anything there. And then that's a nice 24. Okay, that 12 cancels with that 8 cancels with that. So I'm just left with 16 factorial over, what am I left with here? 4 factorial, and looks like there's 3 of them. And then don't forget that was a 24. Okay, so we have 16 factorial. Well, 24 itself was 4 factorial. So if you invert and multiply, it would be basically 16 factorial over 4 factorial to the power of 4. Okay. That is... am I fine? Well, I don't think it's the final answer, but it's getting there. I think I just looked at this, and I think I 1, 2, 3, 4. Sorry, this should have been a 4. And therefore this is a 4. And then therefore this is a 5. Aha. It's a good thing I noticed that. And there's so many 4s in there, I guess I mistakenly missed one. Okay, no problem. Life goes on. Okay, so now we think we're done, but we're actually not, because if you look at carefully, there's that condition that each committee has to have a, what is it called, chairperson and secretary? Yeah, chairperson and secretary. Okay, not a problem. And as I have listed, one person can be the chairperson and another person can be the secretary. But that actually creates a lot of combinations. So for example, let's say you have C1 and S1. There's 4 people, right? And then you have the third person and the 4th person, P3, P4. But think about it. Of the 4 people, we can have 4 choices for the chairperson. And then from the remaining 3, we choose a secretary. And then we basically, the next 2 are just going to be the regular members. So we have 4 times 3 times 1 times 1, which is 12 different ways of choosing one person to be a chairperson and one person to be a secretary. So this whole thing here needs to be multiplied by 12 for each of these. 12 for this, 12 for this, 12 for this, and 12 for this. So 12 times 12 times 12 times 12. So hopefully that made sense. And that is our final answer. And our final answer is 3 to the power of r times m. Okay? So this means this big guy, 16 factorial, 4 factorial to the power of 5, and then this is just 12 to the power of 4 is our 3 to the power of r times m. Okay. So, oh boy, so I've got to get this into the power of 3. Interesting here. All right, so how do I do that? Well, first of all, let me just go back and see what are they want r. Okay. I think I understand. Okay, so I've got to figure out, I've got to basically change this into this format to be able to get R. Since they only want me to figure out the power of R, I really only need to concentrate on how many factors of 3 are in the number on the left side. Okay, let's do it one step at a time. In the 16 factorial, that's going to be, you know, as you guys know, 16 times 15 times 14, blah, 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 right? All the way down to 1. But what we will do, we'll only list the numbers that are factors of 3. So 12, dot, 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 9, dot, 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 6, dot, 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 and 3. And eventually times 2 times 1. So the 15, the 12, the 9, the 6, and the 3. Those have factors of 3 in them, correct? Yeah, so there's 1 here, 2 here, 1 here, and 1 here. Factors of 3. So 1, 2, 3, 4, 5, 6 total. 6 factors of 3. Okay. Now we'll concentrate on the what is it called? The denominator. And in particular, 4 to the power of 4 factorial to the power of 5. Well, that's easy. That's just 4 times 3 times 2 times 1, all to the power of 5. Well, we got 1, but it's power to the 5, so there's actually going to be 5 of those guys. So we got 5 of those. But that's in the denominator, though. And then we have this big guy, 12 to the power of 4. Well, 12 times, again, I'm just going to list powers of 3. 6, and then 3, and then 2 times 1, all to the power of 4. Okay, this, let me see here. 12 to the, oh, sorry. That's not a factorial. Oh, boy. It's a good thing I didn't. That's not a factorial. That's just 12. Okay, I got it. So that's just 12. So 12 is basically like 3 times 4, correct? All to the power of 4. So there's only one factor of 3 in a 12, and then since it's a power of 4, that'll be 4 of those guys. Okay, so that's it. Now, the numerators are this guy and this guy, so we add those, so it'll be 6 plus 4. And the denominator, which is this guy, that one, we would subtract, which is a 5. So 6 plus 4 minus 5 is 5. 5 is what this is, 3 to the power of 5. And then the m, who knows? The m, that's everything else that basically is not a factor of 3. So, therefore, after all that, we get the conclusion that r is equal to 5. And let's see if that's one of the answers. It is. A. The Fibonacci numbers are defined by f1 is equal to 1, f2 is equal to 1, and fn is equal to fn minus 1 plus fn minus 2 for n greater than or equal to 3. What is f2 over f1 plus f4 over f2 plus f6 over f3 plus dot 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 plus f20 over f10? Okay, I think we just have to do this manually. I don't think there is some quick formula, so we have to kind of be quick here. Okay, I'll just do it all in front of you. First, let me just figure out what are these guys. We're going up to 20, right? Okay, so it's not too bad. Because if it was very, very high, like if it went up to F100, then obviously we'd have to figure out some sort of a shortcut or some sort of a pattern. That's also common in these kinds of questions. But since it's only 20, I'll just do it manually. Okay, so these ones are 1, 1, and then you're just using this recursive formula to find all the other guys. So it's going to be 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, 610, 987, 1597, 2584, 4181, and 6765. Okay, so let's just do it. Let's do that thing. So it would be, let's see here, f2 over, so 1 over 1 plus 3 over 1 plus 8 over 2 plus 21 over 3 plus 55 over 5 plus 144 over 8 plus 377 over 13 plus, what's the next one? 987 over 21 plus 2584 over 34, and then 6765 over 55. I should have 10 of these guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Okay. Then if you just add all these guys up, it's going to be 1 plus 3 plus 4 plus 7 plus 11 plus 18 plus 29 plus 47 plus 76 plus 123. And when you add up all those numbers, it is 319. Therefore, the answer is B. Let P at M is equal to m over 2 plus m squared over 4 plus m to the power of 4 over 8 plus m to the power of 8 over 8. How many of the values of P2022, P2023, P at 2024, and P at 2024 are integers? Okay, I guess we have to look at these one step at a time. So it's either 0, 1, 2, 3, or 4, okay, as the answer choices. Okay, here we go. Let's start with P2022, I guess. You plug it into there, and let's see what we get. We get 2022 over 2 plus 2022 squared over 4 plus 2022 to the power of 4 over 8 plus 2022 to the power of 8 over 8. Got it? Okay, that's 11. We have to figure out, I think the only thing we need to figure out are their integers. We really don't need the actual value. It's unnecessary. Is this numerator here divisible by 4? And absolutely it would be, since 2022 has a 2 in it, and it also has a 4 in it, and if you square it, then of course it would have a 4. So that's going to be an integer, I for integer. This guy, all it has to have is an 8, and it most definitely does, because it has a, well, 2022 is an even number, so it has a 2. And if you take 2 to the 4th power, it would be 16, so it's divisible by 8, so that's an integer. And then by the same logic, that would also, that has a 2 in it. 2022 is even, so it has a 2. And if you take it to the 8th power, well, it would be definitely have divisibility by 8, so that's an integer. So this guy is an integer, this guy right here. And you'll see that this number, 2024, because it's even, it will have pretty much the same kind of story. It'll be an integer, an integer, an integer, an integer, and this 2024 is obviously an integer. It's 1012. So for sure, those two guys. Now, the only thing we're not sure about, or I'm not sure about right now, is the odd numbers. And let's see what happens when we explore the odd numbers. So it's not 0, it's not 1. It's 2 for sure, but let's see if we can get any more. So let's just look at 2023 and let's see what happens. So we have 2023 to the power, divided by 2, plus 2023 squared over 4, plus 2023 to the power of 4 over 8, plus 2023 to the power of 8 over 8. Okay, well, this guy is not an integer. It is 111 plus a half. So 1011 plus a half. Okay, not a problem. 2023. Okay, that. Let's see here. What can I do? Well, instead of putting a 1011, I'm just going to put an I plus a half. Yeah. So this guy is really like 2023 over 2 times 2023 over 2, right? I just broke this up. And therefore, that would basically be I plus a half times I plus a half. Exactly what we had here. And then similarly, that guy is 2023 over 2 times 2023 over 2. And we're going to need some more space here. 2023 over 2 times 2023 over 2. Got it? So that's very similar. I plus a half. Let me think about this. How many of them are there going to be? Wait, I think I put one too many. I don't need that guy. Yeah, because 2 times 2 times 2 is 8. Let me think about this for a second. But this is a 4 though. I guess we just have to multiply by a 2023. Yeah. So that'll be I plus a half, and then I plus a half, like that, and then an extra 2023. And then this guy here, that would be same thing, 2023 over 2, 2023 over 2, 2023 over 2, and then 2023 to the 5. And then, yeah, I actually, and then each of these guys is an I plus a half, if you were just to put it in terms of the I's. Yeah, and then this, it's a multiplication, and then a 2023 to the power of 5. Okay, so let's see. This, I'm just going to look at we're going to have a whole bunch of i's, and the i's are integers, so we don't care. We're just interested in what happens with the fractions. When this multiplies by that, that's going to give me a quarter. Everything else is going to be an integer, I squared or 2i or whatever. We don't care. We know those are integers, but what is about the fractional part? The fractional part there is going to be an eighth, and the fractional part here is also going to be an eighth. So let's see what this is. This looks like 4 plus 2 plus 1 over 8, and that's 8 over 8, which is 1. So that's an integer. And when you add that 1 to all the other i's, it'll be an integer. So that means this P2024 is going to be an integer. And I'll write the word. So that is an integer. And then very similarly, by the exact same logic, P2025 will also be an integer. And you can do that in the same way I did it for P2023. So all 4 of them are integers, and therefore the answer is E. Each of the 27 bricks right rectangular prisms has dimensions A times B times C, where A, B, and C are pairwise relatively prime positive integers. These bricks are arranged to form a 3 by 3 by 3 block, as shown on the left below. A 28th brick with the same dimensions is introduced, and these bricks are reconfigured into a 2 by 2 by 7 block, shown on the right. The new block is 1 unit taller, 1 unit wider, and 1 unit deeper than the old one. What is A plus B plus C? Okay, so first let me try to understand this question here. We got to have dimensions of the original, which is this guy right here, and then the dimensions for the new, which is this one. So the dimensions for the original looks to me like 3C, and then how many? Yeah, 3B and 3A. Okay, and then the new, how many A's do we have? 1, 2, 3, 4, 5, 6, 7. So 7A. And then the top to bottom would be 2C, I believe. And then here 1, 2, 2B. Okay. And then if we use that sentence, basically, the equation would be that, let's see here, 3C plus 1 is equal to 7A. 3B plus 1 is equal to 2C. And 3A plus 1 is equal to 2B. Okay, I think that's it. And what do they want? They just want us to figure out A plus B plus C. All right, so this is a system of equations, and I think we should be able to figure this out. I'm just trying to think, do we actually have to figure out individual values for A, B, and C, or can we just figure out A plus B plus C? I'm not sure, but in any case, since we have 3 equations and 3 variables, system of equations is what we will use to figure this out. All right, so here we go. We'll call this equation 1, we'll call this equation 2, and we'll call this equation 3. All right, so what do I do here? Let's add them all. If I add them all, it would be 3c plus 3b plus 3a plus 3 is equal to 7a plus 2c plus 2b, right? And therefore that means, let's see here, 4a would be equal to c plus b plus 3. Okay, I'm not sure if that helps in any way, but that's the first thing I thought of. I think I'll just do it the way I would normally do it, is just make everything in terms of one variable and then stick all those variables into one equation. And you'll see what I mean. So from equation 2, we can get that 3b plus 1 over 2 is c. So I've isolated for c. And then if we sub this into equation 1, then we will get 3 times 3b plus 1 over 2 plus 1 is equal to c, correct? And then that will allow us to get, hold on here, what did I do here? Sub it into 1 is equal to 7a, sorry about that. So that will allow me to get b in terms of a, and then I can sub it into c. Okay, so this one would be a 9b plus 3 over 2 plus 1 is equal to 7a. Multiply through by 2, and we'll get 9b plus 3 plus 2 is equal to 14a. And therefore, 14a minus 5 over 9 is b. Okay. And then finally, we can sub this guy into equation 3. So 3a plus 1 is equal to 2b. So since we have b in terms of a, we can put that in. So 14a minus 5 over 9. Let's move this up a little bit. And let's see here, multiply through by 9. So we will get 27a plus 9 is equal to 28a minus 10. So a is equal to 19. All right, great. We got one variable. Plug that a back into here. We get b is equal to 14 times 19 minus 5 over 9. When you crunch out these numbers, you'll get b is equal to 29. And then finally, sub that into there, and you'll get c is equal to 3 times 29 plus 1 over 2, and that is 44. So we got all the variables, and then if you recall, we just needed to do a plus b plus c, and that will be 19 plus 29 plus 44, and that is 92. And 92 is the answer, and that would be E.